video of Big Data Analytics. In this video, we are going to discuss about Module 4. Module 4 is all about MapReduce, Hive and Pig. So let's start. First, we have a MapReduce programming model. So what is a MapReduce programming model is? It is nothing but a powerful framework. This mainly used for processing and analyzing large-scale datasets into distributive computing environments. It mainly makes use of two components. First is map, second is reduce. In map phase, the input data is split into smaller chunks and distributed across multiple nodes for parallel processing, where each node produces key value pairs as intermediate outputs. So what happens is in the map phase, the input you are taking is mainly divided into smaller chunks, and these smaller chunks mainly what they do is they'll do all the parallel processing, and each node produces respective key value pairs as intermediate outputs. Now the reduce phase, what it will do is we will aggregate these outputs, combining them into smaller, more concise results. So the parallelized approach allows for efficient handling of vast amounts of data. Hadoop, one of the most widely used implementation of MapReduce, utilizes the HDFS for storing and retrieval of data. In such system, nodes serve both as computational unit and storage devices, optimizing the resource use and scalability. So first you have to explain what is map function. Map function is nothing but you are splitting the data into smaller chunks, and now each node will produce its own key value pair and will generate the intermediate results. And the reduce phase, the intermediate results will then, now what it will do is it will join or it will club together and will perform a reduce function. It is mainly seen in HDFS file system for storing and retrieving data, where both nodes can serve as computational units as well as storage resources. It is highly applicable in big data scenarios, enabling tasks like log analysis, data transformation, large-scale data mining. Additionally, what happens is indexing and inner join further enhances the efficiency of data retrieval and processing. Next, you have is the MapReduce. MapReduce employs a master-slave architecture. Again, there's a master-slave architecture here also, which mainly consists of a job tracker as the master and the task tracker on each cluster as a slave. That means you have a, you can say, where is the diagram? Diagram is here. I'll explain with the diagram only better. So job tracking is nothing but the master. Your task tracker is nothing but the slave. Now let's see in detail. The job tracker, that is nothing but the master. Master is responsible for coordinating the execution of a job by scheduling tasks across a cluster, monitoring their progress, and re-executing any failed task to ensure the reliability. Meanwhile, the task trackers, what it will do is it will handle the execution directed by the job tracker operating the cluster's individual nodes. That means the job tracker, that is the master node, is responsible for coordinating the execution of a job by scheduling the task, whereas your task trackers handle the execution of the task directed by the job tracker operating on the cluster's individual nodes. Now the input data for a MapReduce task is mainly stored in files. In files only you are storing, typically within the Hadoop HDFS file system. The files can vary in the format, including logs, binary files, multi-line input records. The MapReduce framework, it will process the entire document as key value pairs, where both the input and output of the task are structured in this form. Now once you are mapping it, you are generating intermediate stages, and those intermediate stages are again going for the reduce part. Whenever the input key value pairs may differ in type, their flexible data model allows wide range of data processing tasks, making MapReduce a robust solution for handling all the big data overloads. Next is map task. The same thing only, guys, not as such difference. It's the map task is mainly seen in the MapReduce programming model. Now what it will do is it will generate key value pairs. The key value pairs has k1, v1, up to k and vn. K is nothing but the keys, v is nothing but the values. K can have n number of strings, whereas v is nothing but the values mainly of any data types. Now output of a map may consist of 0 or more intermediate key value functions, which are act as the input for the reduce task for the further processing. Like first you are applying a map function. Now this intermediate result will again set to reduce. Fine. That means the output of this map function mainly serve as an input to the reduce function. Now this mapper is done. Now the reduce task, what it will do is it will take all these intermediate outputs, process them using a combiner function, and generates a smaller summarized data set. Reduce tasks are always executed after the completion of all map tasks. That means once you are taking the output of the map function as an input to the reduce function, you are applying a combiner function which will combine all the, you can say, the intermediate results, and it will generate a summarized data set. Now we have something known as Hadoop Java API, which mainly provides a mapper class, which includes the abstract map function, which any specific mapper implementation override the map function to its behavior. For example, let's see the structure. How it is happening is, it's an API which mainly provides by the mapper class itself, which helps in the MapReduce technique. So public class sample mapper is the class name which is which extends the feature from the mapper function. The mapper function is mainly consists of values k1 v1 k2 v2. This key1 value 1, key2 value 2. Now you are applying a map function. The map function is applied where you are passing the keys and the values. One second. You're passing the keys and values, and then you are passing the context like what you are trying to perform. Then you define the logic inside the code. The number of map task is determined by the size of the input files. Obviously, depending upon the size of the input file, you are determining how many map tasks can be done. And also the number of map tasks can also be explicitly set up using the set num task int, where you are setting the number of map tasks which you want to do can also be defined explicitly by using the set num map task, where you are defining that how many number of map operation you want to perform on some 10 to 100 per node. Okay. So this is the MapReduce process of all the clients submitting a job. We have already mentioned the master job tracker is nothing but the master which will perform all the map task. The map task, what it will do is it will divide the same the entire data set. If you think, it is divided into many chunks. So this is one slave, this is one slave, this is second slave, it is again the third slave. Again, you have data segments here. What is data segment? Nothing but the intermediate stages. Now intermediate stages, once the output of the map function is taken to the intermediate stage, the output of the intermediate stage will mainly serve as the reduce function. So map output again, you are whatever the output is taken to the reduce function, you're performing all the reduce function here, you are applying the combiner function, you get the final output. So guys, no need to worry. Again, MapReduce is a NoSQL concept. We will study in depth there also. Fine, but whatever was required for BDA, I have mentioned here. And also all these notes are strictly taken from the textbook itself, so that you get the maximum marks in your external exam. Okay, I have avoided the use of any extra other materials, because when it comes to externals you can't risk, so better strictly follow the bookish content only. Now key value pair, each phase of the map and reduce phase has its key value pair as input and output. Data should be first converted into key value pairs before it is passed to the mapper only understand the key value pairs. Okay, very important. Now, key value pairs in the Hadoop is generated as follows. First is input split, record reader. Now, input split, it defines a logical representation of the data and presents a split data using the individual map. That means it mainly defines like what data is present. Next, you have is a record reader. Record reader, what it will do is it will further split the data into different records in the form of key value pairs. Now, once the key value pairs is done, again you are mapping the same into a map task. Diagram only says you have input data in the form of HDFS file storage. Here the input format is present where data is present in the form of any format. You are splitting the input data into different parts, and then you are applying a record reader. The record reader, what it will do is it will mainly generate its own respective key value pairs, and once the respective key value pairs are generated, it will apply the map task. Also, next is in MapReduce, grouping by key operation involves collecting and grouping all the output key value pairs from the mapper by the respective keys. So what happens is the grouping function, the grouping by key operation, it mainly involves all the collecting and grouping of all the output value of the key value pairs from the mapper of the input keys. That means here also you can apply the grouping function also. So what you're grouping nothing but the keys. Okay, now this process is mainly associated where it is crucial for during shuffle and sorting phase. During this phase, all the pairs with the same key are grouped together. That means if similar keys are present, you're grouping it together and creating a list with each unique key. That means if you see some same keys are there, some same pairs of keys will be added up and a unique key will be generated and the results will be sorted. And the output format of the shuffle phase, once the shuffle process complete, data is stored, divided into partition. That means once shuffled, then you are performing partitions. Now partition, what is a partition? A partition plays a very important role when you are distributing the intermediate data into different partition, ensuring that data handling is done across multiple reducers. Again, the same thing, intermediate data which is generated, you are applying partitioner and combiner function to make sure that yes, data handling is done across multiple reducers. Combiner is again optional reducer tool that mainly aggregates or maps the which mainly aggregates the map output records on each node before the shuffle phase, optimizing the data transfer between the mapper and the reducer. Next is the reduce task. Reduce task, what it is doing again by applying the reduce function to aggregate the data and produce the final output. Again, the final output which is produced, which includes the shuffle, partitioning, combiner, reduce phases. It again optimizes the performance and reduce the network load in the distributed system. Again, this is the code for the same thing only. You're declaring a class, for example, reducer. You are extending all the properties from the reducer class. Then you are declaring a function where you are taking a key and a value and a context, like what context you should perform, either a read or a write operation. Next, you are just defining the code where you are just declaring a sum known as zeros, and we're just adding the sum of, you can say, sum of values. Okay. Now, once sum of values is done, we are generating a key, and the sum will be stored in the key. That's it. Next is copying with node failure. Now, copying with node failure mainly Hadoop achieves fault tolerance by restarting tasks that failed during the execution of MapReduce task. First is map task tracker failure. If a map task tracker fails, the task it was running is reset to idle. That means if some of the other operation fails, it's again reset to idle. Then a new task tracker will be reassigned to re-execute the failed task again. So if the map task only fails, what happens is the entire system will be set to idle mode again, and a new task tracker will be assigned which will execute the failed map task. Next is reduce task tracker failure. If a reduce task tracker fails, only the in progress reduce task will be reset to idle. That means if any intermediate reduce task is happening, it will be set to idle. Now again a new task tracker will execute the process to reduce the task. Next is master job tracker failure. Again, entire job is you can say aborted and the client is notified. If there is only one master node, a failure may result in starting the process again from the beginning. That is the main thing, like in case some of the failure happens here. Next is composing MapReduce for calculations and algorithms. In MapReduce, what happens is calculations and algorithms can be composed to efficiently handle a variety of big data processing tasks following other operations. First is counting and summing. Counting and summing is nothing but the operations fundamental to MapReduce task, fundamental operations, counting and summing, where you are counting the number of, for example, you are counting the number of alerts or messages generated during a vehicle's maintenance and for a particular period. Now let's see what is a word count or counting messages in a log file. For each message, emits a key value pair with a key generating a key as a generic identifier and the value as 1. The reducer will sum all the values providing the total count of the messages and the word. That means mapper will map individual you can say word count with a generic identifier, and the value will be as 1, and the values will keep on incrementing, whereas a reducer function what it will do is it will sum up all these values and it will provide the total count of the messages and words. Next is sorting. Sorting is nothing but you are sorting in MapReduce typically occurs by emitting the keys in a sorted order. For example, 1 is the key, 2 is the key, 3 is the key, all are sorted format. Okay, and the framework is made in such a way that they are all the keys are sorted, and the reducer will then aggregate the sorted result. Mapper emits items associated with the sorting keys, and reducer will combine all the emitted parts into a sorted list. Same thing, mapper will make use of the sorting keys, reducer will combine all the parts and will form a sorted list. Finding distinct values. First solution, second solution. First solution, it emits dummy counters for each field and group, and the reducer calculates total number of occurrences. The second solution in the sense like the mapper emits values and group IDs, and the reducer excludes duplicates and counts the unique value. That means first is for counting the unique value, what you can do is either you first let the mapper emit all the dummy counters and you recalculate the total number of occurrences. Second approach is let the reducer exclude all the duplicates and count the unique values in the each group. Then you will get the result. For example, counting unique users by their ID in web logs. Mapper, what they can do is emit the user ID with a dummy count. With a dummy count, you emit the user ID, and the reducer what will do is it will filter out the duplicate user and will count the actual total number of unique users. Next is collating. What is collating? Collating mainly involves collecting all items with the same key into a list. So it is mainly used ETL task. First is mapper reducer. It computes a given function and emits a result as a key, and reducer groups item by a key and processes them. Again, it is mainly used for creating index. Filtering and parsing. Filtering and parsing again when processing datasets to collect only the items that satisfy certain condition and transform them into proper formats. What will the mapper do? Accept only items that specify the condition. Reducer will collect all the emitted items and output the result. Then distributed task execution. Again, the large scale computations are mainly divided into smaller partitions and executed in parallel. The results from each partitions are then combined together to form a final result. Now distributed task in the sense, first we have mapper. Mapper, what will do is it will process a specific partition and it will emit a computed result. Your reducer will combine all the results from the mapper. Next is graph processing. Graph processing, again the same, nodes and edges mainly represent relationships and entities. And mapper, what it will do is each node sends a message to its neighboring nodes. The reducer, what it will do is it will update the state of the nodes based on the messages it is receiving. For example, page rank. Next is cross relation using MapReduce. Cross-relation is nothing but how two sequential datasets are similar to each other in context of big data, particularly in text analytics or market analysis. Cross-relation is used to find the co-occurring items like words in sentences, products brought by the customers. But the use cases mainly found in text analytics and market analysis, where you are finding the words that co-occur in same sentence or document. That means the words which are occurring in the same sentence or document many times. And also it is seen in market analysis, where you are identifying the products, identifying which products are often bought together. Example, customer who has bought item X also tend to buy item Y. Let us see the next topic, that is MapReduce approaches for cross correlation. So there are mainly two main solutions for obtaining the cross correlation using the MapReduce technique. First is the first approach. That means you're emitting all the pairs and dummy counters. How will you do is, in this approach, the mapper will emit all possible pair of items and dummy counters for each pair. The reducer then sum up these counters. The first is the mapper step. Mapper step, what it will do is it will emit the pair of items with a counter of 1. For example, if I take a list of all the fruits like apple, banana and cherry, it will emit the following combinations like apple, banana, 1 is the counter, apple, cherry, 1 is the counter, banana, cherry, 1 is the counter. The mapper will do. The reducer, what will do is it will sum up all these dummy counters. It will add all these dummy counters for each item to compute the total occurrence of the count. That means it will check how many times apple has occurred, how many times banana has occurred, how many times cherry has occurred. Now, if the pair apple, comma banana appears in 3 sentences, the reducer will sum the counters for this pair to give the final count. If it finds that yes, apple has occurred twice or thrice, it will give the sum of the counters of this pair. That's it. Next is the second approach, that is using stripes. Using stripes for efficient computation. Using stripes, what you are doing is, when the data set is very large, emitting all pairs directly may not be such efficient. So using a stripe technique is used, which groups the data by first item in the each pair. So you're taking the first item in the each pair and then using a stripe method. So what happens is, first is the mapper function. The mapper groups all the adjacent items into an associative array. The stripe will keep track of the co-occurrence count for each item in the tuple. Now let's see, for this is the list. Now the mapper will emit first, let's take the first item, that is apple, banana 1, cherry 1. That means one by one items we are taking and we are assigning a counter of 1. The next banana, next cherry. Similarly, the combination has apple, cherry, apple, banana, then cherry. Then reducer, the reducer will then merge all the stripes for the same leading item, that is for the each unique item, aggregate the count of for each co-occurring item and emits the final result. That's all about what are the two approaches for MapReduce techniques. First is you will directly emit all the pairs and dummy counters. You are taking all the combinations. Secondly, you're making use of stripes. Okay, and then you are counting the you say I mean then you count the aggregate total of occurrence of each item. Next is relational database of relational algebra operation, similar to that of your SQL, only used to manipulate and retrieve data from the relational databases. First we have is a selection operation. Selection operation is mainly used to select a subset of rows from a relation and then satisfy a given condition. Now the result of a new relation mainly contains only those rows from an original relation where a condition holds true. That means selection is mainly help you to give only those particular subset of rows where you are satisfying a particular condition is holding true. Syntax is sigma condition R, where condition is nothing but a predicate that the rows must satisfy, and also R is nothing but the relation from which the rows are selected. Now let's see an example of this. Consider we are having a relation of known as employees with attributes like employee ID, name, age, and department. So first we have this employee ID, that is 101, 102, 103. Name is Alice, Bob, and Carol. Age is 30, 25, 35. Department is HR department, IT department, and HR department. Now for example, if I want to perform a select operation, select only, right? Selection operation. Now let's try to have a query. If you want to select employees from the HR department, we would write sigma department is equal to HR. So that means here we are giving the condition, like what should be the condition for that. Here is the table name, followed by that applying the sigma operation. It's nothing but selection operation. This would result in the following relation. Like once if you are trying to query this, you will get this as the particular result. You want only those information, or you want only the subset of the rows where the department is HR. You will get 101 and 103. You see 102 is from IT department, so obviously that result I won't get. Next is projection. Projection, what we'll do is it is used to select a specific column from a particular relation, effectively reducing the number of attributes in a resulting relation. What it will do is it will eliminate all the duplicate rows in a result. It is mainly represented by pi, where you're adding all the attribute 1, attribute 2, and goes on. Okay. Attribute 1, 2 up to n are nothing but the columns to be specified, and R is nothing but the relation from which the attributes are selected. Let us consider an example. Consider the employees relation again. If we want to select the name and the department column, we would write pi name comma department employees. So what is the format here? Just give the this is the operation for you can say projection. So projection, what you're doing is you're putting the attribute names. What is the attribute name? First is the name. Next is the department. Once you are done, you are passing the, what is that? The relation table ka name you have is employees. Fine. You get this result: Alice, Bob, and Carol. Because why we got name and department? Because we have asked, like, from the employee relation we want the name as well as we want the department. So with this two we got this table. Next is union. Union is nothing but you are combining the rows of two relation, removing all the duplicates. That is simply R union S, where R and S are two relations with the same schema. Okay. Now let us take this example. For example, we have an employee table and we have a contractor table. It has an employee ID 101, 102, Alice and Bob. Again, an employee ID 103, 102, Carol and Bob. You can see this Bob and this Bob are nothing but they are duplicates. Correct? So now once you are trying to perform a union operation, you have to make sure that you are removing all the redundant pairs. That is 101 is unique, it will get printed. 102 it occurring twice, so twice it won't, but yes, once it has to be present. Now next is Carol will be printed. That means duplicate entry of Bob was eliminated. Next is set difference. Set difference nothing but R minus S, which are present in R but not present in S. Correct. Now R is the first relation, S is the second relation. So if we subtract the contractors from employees, the result will be 101 Alice, because it mainly mentions that whatever it is present in A but not in B. That means you can say B has occurred twice. That means which is present in R and not in S. That means R was in R, Alice was present at both the times. So Alice will be there, but Bob is excluded because it is mainly occurred twice in both the employee as well as contractors. Next is the Cartesian product, nothing but known as cross product. You are taking every row of one first relation with every row of the second relation. Fine. So this is the two table S and 2 considered two relation. First is the employee relation. Next is department 101 Alice, 102 Bob. Department D01 HR, D02 IT. Now you are applying the Cartesian product. That is, you are just doing the cross the Cartesian product. That is, you have to just multiply 101 into Alice by this into this, this into this, then this into this, this into this. 101 101 Alice D01 HR, 101 Alice D02 IT, 102 Bob D01 HR, 102 Bob D02 IT. Just performing, just cross the you can say you are just joining, not joining, applying Cartesian product, multiplying the two tables. Okay. Next is rename. Name only says you want to rename a particular attribute of a relation or to change the name of the relation itself. It is mainly given by row. You are adding the new name here, provided the old name. I guess this you have already studied in your DBMS, so it's nothing, just a revision part only. Fine. Again, what's the harm of doing this? Doing it again. New name is nothing but the new name of the relation. Old name, current name of the relation. R is the relation. Now, this is the what you say. Example what you've done is first we are taking from the employee, this is nothing but the relation name piece. Now in relation name, what you are doing is you are trying to do this thing. You are trying to update one particular attribute. For example, EMP ID was there in previous. I want to change it to proper employee ID. Okay, so just this is the operation. Row of employees is nothing but the relation name only, where you are just targeting the EMP ID to change into proper employee ID. You have changed this. See. Next is join operation. Join operation, again, two types of operation are there. First is based on a common attribute, you are performing a join operation. First is inner join, then you have outer join. In inner join, what you are doing is combining rows from both relations where join condition is true. Outer join returns all rows from one or both relation with null values. This is R and S are two relation. So you are performing join operation by this way. Okay. R and S are relation. Condition is also there for doing a join operation also. Now, let us consider this example. We have an employee relation as well as a department 101 Alice, 102 Bob, 101 HR, 102 IT. Now, to perform inner join operation, what it will do is for doing an inner join operation again, you can see the EMPI, the employees table. In the employees table as well as in the employees table, we have EMPID. So department table, we have EMPID. That means a common attribute is present. So being a common attribute, what we can do is directly you can apply a you can say inner join operation, that is just multiply the same, that is 101 Alice 1, 102 Bob, HR and IT. That means 101, 102 is nothing but the employee ID is common. Keep it one side. Okay, 101 and 102. Name is Alice and Bob. Now HR and the IT department. Done. That's all about the basic, you can say, SQL operation. Next, let's see what is Hive. Hive is again data warehousing, much more important. Remember the keywords: data warehousing, SQL like query system built on the top of Hadoop only. This is developed by Facebook and manages huge amount of data, mainly works on HDFS file system only. It is mainly used for process of querying and managing large scale data sets by providing abstraction layer, which help you to run all the SQL queries on the top of the Hadoop ecosystem. Next is characteristics of Hive. First is MapReduce integration. Like, yes, we are making use of MapReduce techniques, which we can easily help to, you can say, run the SQL queries. This makes Hive highly scalable and suitable for managing and analyzing vast data sets. Also, it inherits scalability and parallel processing of Hadoop. Next is web and API support. Web and API support, what happens is you mainly allow clients to interact with the Hive database. So, okay, fine. The clients will mainly interact with the Hive database either with the form of web browser or programmatic access, making it convenient for both the developers. Next is SQL like query language, similar to the my sorry MySQL server. The HiveQL make uses of HiveQL Hive query language, which is similar to SQL. It also allows user to perform typical database operation like select, insert, join, group by, and performs all the CRUD operations as well. Next is data storage on HDFS. Again, data is loaded into Hive tables again, for which is stored in the HDFS form, in the HDFS files system only. Hive mainly abstracts away the complexity directly, and users can interact with the data through Hive queries. That means by making use of Hive QL queries, you can also interact with the data which is present. Next is the limitations of Hive. First is not a full database. It's not a full database. Sometimes you can say critical operations like update, alter, and delete. These operations are sometimes not supported by the Hive. Okay. The design of Hive prioritizes read-heavy analytical workloads rather than transactional operation. Next is unstructured data handling. Unstructured data handling is mainly Hive is mainly designed for all the structured and semi-structured data. It is not optimized for unstructured data. That means unstructured data it cannot work, but it's well suited for all the structured as well as semi-structured data. So it may not be the best tool for all analysis of real time. So sometimes what happens is it may not be a best tool for your unstructured data processing. Okay, it may not give you proper results. Next is real-time query limitations. In real-time query limitations, it performs best in batch processing scenarios where it make it less suitable for interactive real-time analysis when low latency queries are needed. So sometimes what happens is low latency queries are needed, and it does not generate many fast response. So fast response sometimes is a problem here. You don't get the immediate fast response when you use a Hive database. Next is partitioning from the last column. One limitation of Hive is the partitioning strategy. It's very difficult to partition it. When creating partitions in Hive, the partition is done based upon the last column, but depending upon whatever value is there on the last column, we are doing the partitioning. So sometimes it can be very much problematic. Next is use case of Hive. Use case of Hive is data warehousing first. Like, where are you using it? Hive is commonly used in large scale data warehouse applications where you are handling a large amount of structured data stored in HDFS. Next is batch processing. Batch processing, you are making use of map reduce execution model, and also you are making use of ETL techniques for operations as well as aggregation. Next is data analytics. Analytics in the sense mainly make uses of data sets in industries like e-commerce as well as your finance, telecom, where data is typically stored in HDFS, querying, extracting information and large volumes of static data. That was all about your use cases. These are the features of Hive. First is file formats, ETL support. Any file format it can support mainly the structured as well as semi-structured. Unstructured it cannot support. Okay. ETL support for extract, transform, and load. Hive query language for querying the data. Open source is easily accessible to everyone. Again, table structure is there. Then query processing. Next, very important for externals, double, triple star. Okay, I don't know how many times it has appeared in the exam. Next is Hive architecture. Hive architecture is nothing but it is designed to provide an abstraction layer on the top of Hadoop. It is mainly used to run SQL queries for analyzing large data sets stored in HDFS. So how the entire thing works? This is the entire diagram. You have a Hive client, you have a Hive services. The Hive client mainly consists of thrift server, JDBC driver, and ODBC driver. The Hive services mainly consist of the UI, Hive server, CLI, Hive driver, and Metastore. Then you have a MapReduce framework. On the top of it, it is built on the HDFS structure. So diagram is very much important. You have to draw this diagram, and the explanation is there as follows. First is the Hive server, thrift. The thrift server, what is this used for? The Hive server thrift service is nothing but an optional service that allows remote clients to submit requests to Hive and retrieve the result. That means you are just retrieving something from the, or you are requesting something from the Hive server. Okay, you're also making use of client APIs here. Client API, what will do is simply it will help the execution of Hive HQL statements, because whatever request you are making is in the form of queries only. So all the Hive QL commands are mainly working with the help of the client APIs only, and the client, and it also supports various programming languages such as Java, Python, and others. Next is role. What is the role of this? It mainly acts as the interface for external applications to communicate with Hive system. Also, the thrift service allows clients to send HiveQL queries and retrieve results without interacting with the infrastructure. Okay, that means also it can the thrift server mainly allows clients to send all the Hive HQL queries, and you can retrieve the result without interacting with the infrastructure as well. Next is the Hive CLI, the command line interface, nothing but which allows users to interact directly with the Hive through the command line. Okay, now what is the local mode? Hive can run in local mode. When it be used in this mode, Hive uses local system for storing the data rather than HDFS. So when in Hive, in CLI mode, what happens is you're making use of the local storage, local file systems for storing the data, and whatever the usage is, it's mainly used for submitting the queries, manage database, create tables, and perform all the administrative tasks. Next is web interface, HWI. It is mainly access to Hive web interface. Okay, HWI server, it must be, it's nothing but it's a website. And also provides website for the, you can say, for the Hive model, and also it provides the graphical interface for executing queries, managing tables, and also performing administrative tasks over the CLI. Next is Metastore. What is Metastore? Metastore is nothing but a crucial component of Hive that stores all the metadata information. Next is related to the tables, database, and columns. Also, it stores metadata, which is nothing but the information about database, schema, and column data, everything. And also, it maintains interaction between the Hive and the other components. So Metastore, what it will do is it will mainly interacts with the Hive driver. The Hive driver, which again interacts with the UI, the server, as well as the CLI. The diagram, only if you draw it properly, you can explain in your own words. But still, some key points are very much important. You can't skip that. That's why I'm giving the detailed explanation. Okay. Next is the Hive driver. What is Hive driver? Hive driver is again manages the life cycle of the HiveQL query. Next is how you're managing the life cycle. Again, whatever query you are writing, it has to be compiled. You have to optimize it and execute the query in a Hadoop cluster. Now, what is the execution flow? First is the compilation process. Once you compile it, then you optimize. Once you optimize, then you execute. That is compile, optimize, execute. Then what is compilation? Compilation mainly compiles the HiveQL statement into a series of MapReduce job. Fine, that is the main task of compilation. You are just compiling the HiveQL statement into a MapReduce job. Okay, this HiveQL into MapReduce. Now optimization, what you are doing is you are just you can say optimizing the query, in the sense you are just doing some process like predicate pushdown, then column pruning, and join optimization in order to make optimization. You can say in the sense you can say like whatever query you are putting, it has to be executed very fast. It should not consume too much time, right? So that's why you are optimizing it, like finding methods to enhance the code. Okay. Execution, the final optimized query is submitted for the execution in a Hadoop cluster where it is processed by the MapReduce framework. Next, you have query compiler. Query compiler, the name only says, it mainly helps in parsing techniques, where what happens is the process involves compilation of the HiveQL statements. Whatever HiveQL statements that you have done, it is mainly converted into an abstract syntax tree, your AST tree, and then it is applied for optimization before the result is produced. Once done, it is sent to the execution engine. Execution engine mainly responsible for the actual execution of the query. Next is processing. Once done, execution over. Now what you have done is you have submit the task to underlying hardware infrastructure. That means you are submitting the query to the underlying Hadoop infrastructure. That's it. Next we have is the Hive data types and file formats. So it has a lot of like, it can mainly define primitive, complex, string, collection of data types and file formats for handling and storing the data. So let's see everything in detail. First is What is the difference between the RDBMS and Hive? So RDBMS is used to maintain database, whereas Hive is a data warehouse. Okay, database, data warehouse. Query language, it will use SQL, it will use HQL, Hive query language. Schema flexibility, schema is fixed. Here, schema varies. Okay, now data normalization, it is strictly follows normalization, whereas it is not strictly followed here as in Hive. It can be denormalized as well, depending upon whether it is which type of normalization it follows. Okay, then table structure, mainly tables are mainly present in RDBMS, and also it is sparse, whereas in tables in Hive is very much dense. Then it does not support partitioning. You can't partition a RDBMS table, whereas you can easily partition a Hive table using automations. Then partition method, no partition method is used here. Sharding method is used. Now, what are the data types used? Again, you have to remember this by heart. For int, we have 4 types. Int is itself a tiny int, a small int, normal int, and big int. Tiny int, a 1 byte sign integer, postfix with letter Y. Small int, 2 byte integer with postfix with S. Normal integer, 4 byte sign integer. Big int, 8 byte with L. Then we have a float, double, boolean, timestamp, date, and varchar. Your double float and double is mainly used for precision of floating point numbers. Boolean will store in the form of true or false. Timestamp will take the you say the information, the current date time from the server, that is y, dd, as well as time will be ss. Dot ffff in the sense the you can say, what do you mean, the exact milliseconds also it will take. Okay, next is date. You have done varchar in the sense of the single you can say strings, you can whatever you store in varchar, similar to your RDBMS. Okay, char 255 bytes, then decimal used for representing immutable arbitrary precisions. Then you have the types of file format. First is text file, sequential file, RCF file, ORC file. The text file is mainly consist of your default file format, where you are just text file. Examples are JSON, TSV, JSON, XML, CSV file, XML file. Your sequential file mainly consists of your key value pairs and the support compression. RCF file mainly it's a record columnar file, and ORC file is an optimized row columnar file, which means that it is mainly stored data in an optimized way than other file formats, like way of storing of data only. Next is the Hive data model. The Hive data model mainly organizes data, organizes and structures the data in a way for efficient querying, analysis, and Hadoop ecosystem. Like Hive data model will mainly make use of 3 things. First is database, tables, partitions, buckets. Database, the name itself says, in Hive acts as a namespace for organizing and storing the table. For example, student database, let us consider. Okay, that is a database name. Here it is also known as namespace. Now inside the student database, again you will have tables. Next you have is example, again same thing only. Now next you have table is nothing but they are used to store the structured data in a tabular format. Each table is backed by a directory in HDFS. The actual data files reside. That means again, whatever tables, whatever you are creating inside a database, it is linked to the directory of HDFS. So what are the operations supporting? First is your filter, projection, join, and union. Your filter is nothing but filtering rows based on a condition. Projection, you want to take some specified columns. Okay, then I guess you remember this is the pi operation for projection. Then you have sigma for selection, everything. Next you have join, where you want to join multiple tables. Then is union, you want to combine result from multiple queries. Done. Now once you are done with all this operation, you have to store it somewhere. The data in the Hive table is mainly stored in HDFS, and the structure is defined by creating the table only. Next is partition. What is partition? Partition is nothing but you are dividing the data which is present in the table into subsets based upon the values of one or more columns. Okay, it mainly helps in efficient querying by reducing the number of data scanned for the queries. So how it works is basically you are just dividing the information which is present into a table into different columns. Now this will help you to generate the result of the queries more efficiently by scanning the data. Okay. Next is example, a sales table can be partitioned by the year and month columns to store data for each and month separately. Next is bucket. What is bucket? Bucket is nothing but you are buckets further divide data within each partition based on a hash of a column in a table. Like you are dividing the data set on based upon the column. Each and every information will be stored in a bucket. The buckets will indeed it's a split into a smaller and more manageable files within each partition. That means it's a way of storing the data only. Correct. Now how it works, data is mainly divided into individual number of buckets by hashing a particular column value. Each bucket corresponds to one file in the partitions directory. That means like data whatever it is there, it is mainly divided into different buckets. It is distributed into different buckets by means of a hash value, and then you are performing the set of operations. That's it. Next is the Hive integration and workflows, how the work mainly happens. First is the Hive user client interface. Then first operation is there is a driver, then compiler, then metastore, then again from this the result comes back to the compiler, from compiler to driver, from driver to execution engine, from execution engine to MapReduce. Once MapReduce is done, you are interacting again with the execution engine as well as the metastore, and after that the reduce function is again set back to the execution engine. Let's study this in detail. First is execute query. Name only says execute the query now. Now what happens is the query, whatever it is present in the client interface, is sent to the database driver, which is responsible for initiating the execution process. From here, it will come to here, the query. Now, once the query came here, what it will do is it has to forward the same into a query compiler. What the query compiler will do is, it will, what does a compiler do normally? It will check for syntax, correct? It will verify the syntax, it will check whether everything is in a proper format or not. So, it will verify the syntax and determine the operations required. Okay, get metadata. Get metadata in the sense compiler now once the compiler gets the query, it will request metadata, the metadata which is present in the meta store, where it will be interacting with the databases like PostgreSQL as well as MySQL. It will interact. Now once it is done, it will send the data again. Now metastore will indeed send the response with the metadata, and the compiler uses this information to refine the query plan. Like once it gets once it's the compiler sends the, you can say, the query to the meta store. Once it gets the particular information, it will again send back to the compiler. Once you send it back to the compiler, again the compiler will send it back to the driver. Once the driver get back the query, after the parsed query, it is again sent to the execution engine. Execution engine, what it will do is it will help you to run the query on a Hadoop cluster. Once it is done, it will execute a particular job. There is nothing but a MapReduce techniques will be there, where the job is mainly sent to the job tracker, which is nothing but the master. Okay, and task tracker is nothing but the slave. You're performing all these operations. When it is done, the once read and write operation you have performed, again the information is fetched back to the execution engine again. Okay, now you are querying the schema details and update the metastore. You get back the original information, then you fetch the result. Fetching the result, the execution engine collects the results from the data nodes the job was processed. Next, send results. The results will again send back to the driver, which in turn forwards them to the Hive interface and display to the user. Same thing again, I'll summarize the same. First you have the user client interface. What it will do is it will fetch a particular query. It is sent to the driver. Once it is sent to the driver, it will send to the compiler. Compiler, what it will do is it will check for syntaxes, it will generate the parse tree and everything. Once done, it will send to the metastore. Metastore, it will interact with the other databases. For example, MySQL, PostgreSQL, MongoDB, whatever it is there. Then once it is done, it will again, you get the information, you have done the query, you have checked everything, you will get it back to the compiler. From the compiler, again back to driver. From the driver, you are sending to the execution engine where the actual query is executed. Once it is executed, again you are sending it to the MapReduce process where you are performing all the master slave operation. Here is nothing but the read and write. Understood? Yes, read and write operation. Next, again, after you perform read and write operation, we go back again to the execution engine. From the execution engine back to the driver, and then you get the result. That's it. Next is built-in function. Again, it is explained from there only, from the table itself. Big int function, what you will do is big int, the name only says 8-byte integer. It takes, example, you give one for double floor, that is double it mainly. You can say it returns a maximum big int that is equal to or less than double value. Seal method, these are all inbuilt function, guys, inbuilt functions of Hive. So first is big int function. Then you have is the random number function. Random number function is generating a random number between a particular range. Then string functions, you are performing operations like concatenation where you are joining two strings. Then you're performing a substring operation where from a bigger string you are extracting a smaller substring. Then you have substring, string, str, start and length. From a given string you are supposed to find a particular substring with having a starting letter s and starting letter and an ending letter. Okay, so next we have this uppercase and lowercase. For start from lowercase will be converted to uppercase and lower to upper to lower and lower to upper, vice versa. Okay, that is all about the, you can say, the Hive built-in function. It's basic. What will I explain? You also know all those things. Next is trim. Trim is nothing but remove the all the white spaces. Then L trim is nothing but from the left side of the string you are trimming it. R trim is nothing but from the right side of the string you are trimming it. Next is data and time functions. Same. First extract the part of the year, y, month. Same, if you want to return the month, then particularly the method is month bracket string date. You're getting the what is that, the number of months. At the same time you get the number of days as well. Okay, these are the methods for extracting a particular year, month and a day. Next, you have is the HiveQL features. Again, data definition, data manipulation, query processing. The data definition mainly helps to define and manage the schemas of tables and large databases. Data manipulation mainly helps inserting, updating, deleting the record. Query processing mainly helps in querying large data sets like filtering, joining, and aggregating the data. Again, HiveQL process engine consists of execution engine which executes the data. Also, Java-based MapReduce programs are there which will help you to help in MapReduce techniques. Also, yeah, the same thing, only it's repeated here, so not required a further explanation. Next is what are the commands? How will you use a HiveQL language? It uses several commands for defining databases and tables. So first is creating a database. Creating a database, what is the command? Create database. Okay, create database with the name. Why not if not exists? Because if by default a database name is created, again you can't create a database with the same name again. So we are making use of the command if not exists. Ensure that Hive does not throw an error if database already exists. Okay, my database is my database name. Now to show all databases, what you have to do is the command is show databases. It will show the whatever databases are present. So when this command is executed, my output will be my database. Correct. Next is dropping a database. Dropping a database in the sense for deleting an existing database, we use the following command: drop database if exist, restrict and cascade with the database name. Now, if exist in the sense, we have to first check if you want to delete a database, it should be present first. Because if it is not present, what will you delete? Right. That is if exist method. Next is restrict. Restrict in the sense that delete the database only if it is empty. If an empty database is present, then only you delete it. Next is cascade. Cascade in the sense delete the database along with any table it contains. That means if a full, you can say a full dense database is present with all the information present, with the cascade method, the whole database gets dropped out. This is all about creating a table. Creating table, create, then create temporary external, like a temporary external table which you want to create with. If it does not exist, you have to create the table with column, row format, and stored as whatever format you want. First is temporary. What is this temporary command? It mainly creates a temporary table that is only available during the session. A temporary table is created. Next is external. External in the sense Hive won't manage its data. That is data is stored outside the data warehouse. That because HiveQL, what happens is all the data is stored outside the Hive warehouse. So you're making use of this external command. If not exist in the sense avoids an error if table already exists. You have to create it. Correct. Next is comment. Add a description to the table or column. Row format in the sense specifies the format where how you want to store in a row format or a columnar format. Next is stored as how will you store the data, either in text file, ORC, or a parquet. Like create table, you have to create a table if not exist. Matlab, if the table is not there, you have to create the table for the employee database as emp id will be integer, name will be string, salary will be double. Okay, now comment in the sense you are adding a description to the column that yes, this is the employee table. Now row format delimited, that means nothing but you are specifying that yes, everything should be in a row format only. Fields terminated by comma, that means employee id int comma. This comma suggests that yes, this is one particular column name of a particular database. Next is terminated by comma, stored as a text file. That means if you're creating a table, the moment you are saving it, everything will be stored in a text file. Next, HiveQL data manipulation language, that is DML. This was DDL. Remember guys, don't forget this. This is DDL, data definition language. Next is the data manipulation language. Data manipulation language, what you are doing is again you are managing and modifying the data. First, using a database, first use the database which you want to use it. For example, student database, use the student database. Now load the data into a Hive table from the local HDFS path using the particular command. Now once you are using a particular database, you are trying to establish a relation or you want to link with the student database. Now you have to load all the items into it. How will you load? The first you have to put the path. Obviously, first is load data. You put the local path name and then into this particular table. What is this local will do? Now this local specifies the file on the local file system. That means where it is present in your system. Then overwrite. Overwrite mainly overwrites the existing data table. Next is partition. Partition, what it will do is it will specify the partitioning of the columns if possible. Next, dropping a data table. That means if you want to drop a table, just drop it out. If you want to alter a table in the sense if you want to change the name of a particular column, you can add alter table, table name, add column. With the column name, you mention the data type and then you comment it. Comment in the sense add a description like what is the new entity all about. Next is Hive querying the data. Like how will you query? A basic query of HiveQL is here. Like first is select from where all are SQL. You already know. Even all are SQL commands only, nothing difference is there. Group by, having, cluster by, no, cluster by was not there, distribute by, sort by, limit. So first, let's see, we have is all is nothing but you are getting all the return all the rows. Distinct in the sense return only the unique rows. Then where, filters rows based on a condition. Group by, where you are grouping is there based on a specific common column values. Then we have is having in the sense you are filtering the groups based on a condition. Then cluster by, what is cluster by, you are grouping the rows and then sorting them in a specified way. Then distribute row to a different reducers. Then sort by, sort the data within each reducer. Then limit the number of rows returned. That means each and every command you have to remember where you are using cluster by to group the different group the rows and sorting them in a specific way. Your distribute by is nothing but you are distributing the rows to different reducers. Sort by, you are arranging in ascending or descending order. And limit in the sense like how many number of rows you want to get returned. Well, like how you have implemented all the Hive QL queries. So first is select a distinct name and salary. What you are doing is you're selecting all the distinct name and salary from the employee table where the salary is greater than 50,000, and you are ordering the entire this one. The column should be the salary column I need in a this descending order. So this is done. So next we have is Pig. Okay, Pig is nothing but a high-level platform built on top of the Hadoop to facilitate the processing of large data set. It abstracts the complexities of writing the MapReduce programs and provides a more user friendly interface for data manipulation. That means in Pig, what you are doing is, again, it's a high level platform only for which is built on the top of Hadoop for processing the large data sets. And here it will not use any kind of your MapReduce program. It abstracts these complexities and it provides a more, you can say, a better user interface, which is mainly helpful in your data manipulation. First is features of Apache Pig. First you have is the data flow language. Pig uses a data flow language where operations on the data are linked in a chain. Output of one operation is the input to the next. That means one after the another it is linked. Correct. Next is simplifies the MapReduce. Pig reduces the complexity of writing the raw MapReduce programs by providing the higher level of abstraction. Next is parallel processing. That means again execution of tasks in parallel, which makes them to handle the large data set. Next is flexible. Flexible is mainly supports all the structured, semi-structured as well as the unstructured data. Then high level operation. High level operations will mainly help in filtering, joining as well as aggregate operation. But the applications now, first is large data set analysis, which is mainly built on the top of HDFS. Next is ad hoc data processing, mainly helps in quick one-time data processing task. Okay, processing streaming data, it is nothing but your weblogs, sensor data, and other real-time application. Next is search platform. Search platform is mainly used for processing and analyzing the data trends. And also time sensitive, which mainly helps for, it requires and analyzes data quickly, which is essential for application that require the insights. Next is Pig architecture. First we have is the Pig Latin script, then Grunt shell, Pig server, parser, optimizer, compiler, execution engine, MapReduce process. This is the Pig architecture. Okay. So Pig architecture is mainly built to support the flexible and scalable data processing in a Hadoop ecosystem. It mainly executes Pig Latin scripts. Okay, via three main methods. So what are the three methods of executing a Pig Latin script? First, the grunt shell, then you have a script file, then you have an embedded script. The grunt shell is nothing but an interactive shell which executes the Pig scripts in a real time. It will help you to execute your Pig script. Now, what is a script file? Script file is nothing but a file which contains all the Pig commands, which has to be executed on a server. Then you have the embedded script. Embedded script is nothing but, it will have all the user defined functions in different programming languages and is embedded within the Pig script. That means inside a Pig script you have an embedded script also. So again, this embedded script will contain all the user-defined functions, which is present again in different programming languages, and all are embedded in the Pig script file. So what is the Pig execution process? Like first is a parser. What is a parser does? After a script passes a grunt shell or a Pig server, the parser handles the syntax checking and type validation. So what it will do is it will mainly check for the syntax and the validation of the query, whatever you are passing. So what it will do is in this step, it will produce a directed acyclic graph DAG, which represents the flow of operation. So DAG is nothing but the nodes represent the operations and the edges indicate the data flow between them. This structure ensures that each node only handles one set of inputs at a time, making the process more acyclic. That means your parser, what it will do is it will generate all the acyclic directed acyclic graph, which is nothing but a parse tree it will generate, which mainly checks for the syntax and everything. And in the DAG, the nodes represent the operation, whereas the edges indicate the flow of the data, like how it is going to execute. Okay. Then next is optimizer. Optimizer in the sense, after generating the data from the DAG, the optimizer reduces the data at various stages to optimize the performance. That is nothing but you are optimizing the performance. You are making the you are just enhancing the query. Okay. First is push-up filter. Push-up filters mainly helps to reduce the data set early in the pipeline. We are using certain filters like splits and push-ups. Next is push down. Push down, what you are using is you are delaying. You are trying to minimize the data set in the pipeline. So mainly push-up filters and push down filters mainly used for reducing the size of the data set. Next is column pruner. Column pruner in the sense, remove the unused columns as early as possible. If something is not required, just remove it off. Next is key map pruner. It will discard all the unused map keys. For example, some of the keys are not used, simply remove it off, not required. Next is limit operation. Limit optimizer. Limit optimizer, what it will do is it avoids pushes the limit operation as early as possible to avoid unnecessary computation. For example, if the operation, if the in the series of operation, if one step is not required, so we can make use of this limit operation to stop this unnecessarily process. Next is compiler. Compiler is nothing but the Pig scripts are converted into a series of MapReduce jobs which are compiled into the code and has to be executed on a Hadoop cluster. Next is the execution engine. Execution engine executes them on a Hadoop cluster, generating the final output. Okay. So first you have the Pig Latin script. Pig Latin script, what it will do is it will interact with the grunt shell. The grunt shell and all, it will what it will do is it will execute the Pig Latin scripts. In the Pig Latin scripts will be again sent into the parser. Now once it is sent to the parser, it will check for all the you can say syntaxes and everything. It will generate a parsed tree and related acyclic graphs where you establish a relationship between the nodes and the edges. Once done, you are sending it to the optimizer where you are trying to optimize the code by using push up and push down filters. Once it is done, you are sending it to the compiler. The compiler, what it will do is it will send it back into the execution engine, and the execution engine will execute that particular query. Okay, and then you get the final output. So next we have is the what are the Pig grunt shell. What it does is the main primary function is to write and execute the Pig Latin scripts. Okay, to execute the shell commands, this is to execute grunt greater than the command name you have to put. Next is the Pig Latin model. Pig Latin data model mainly contains both primitive as well as complex data types, making it versatile for handling all the data structure. First is int, long, float, and double. Primitive data types are these only: char array, byte array. Integer 32-bit signed integer, long 64-bit signed integer, float 32-bit floating point. You have to mention all these things: 64-bit floating point, character array, as well as binary data. Complex is nothing but bag, tuple, and map. Bag is nothing but collection of tuples. You can say with curly braces. Then ordered set of fields where you are just putting the information in a first in what do you say that round brackets. Then map is nothing but key value pairs. Pig Latin constraints. First is schema and expressions. What are the Pig Latin construct. Pig Latin construct says that how they are built and they can perform a variety of operations that handle the user input output transformation. First is schemas and expressions. Schemas and expression mainly defines how data is structured and operations will be performed. Next is command, load, dump, and store. Load is nothing but you read the data from the file system. Dump is to display the result. Store is like you store the process result back into the file system. Next is comments, single line comment, multi-line comments. Again, same thing. Single line comment starts with this line. Multi-line comments with hash star, then star hash. Okay. Case sensitivity. Yes, keywords like load, store, dump are not case sensitive, whereas the function name, relations, everything is case sensitive. Then what are the execution modes? First is interactive mode, batch mode, embedded mode. Interactive mode, what it is do is the grunt shell, what it will do, the grunt shell will help you to write and execute the Pig Latin scripts, making it quicker for testing and debugging. Okay, this is for the interactive mode. Batch mode, what it will do is in this mode, you write the Pig Latin script in a single file. You are writing the script in a file with the .pig extension. Now this script will be executed. Like in spite of putting the script into the grunt shell and then you're asking them to execute, you are just storing the Pig Latin script in a single file with a .pig extension in batch mode. Okay, next is embedded mode. Embedded mode mainly makes use of user-defined functions, UDFs, which supports various programming languages such as Java, and then it will execute my script. What are the Pig commands? To get a list of the Pig commands present, the command is pig-help. To check the version of the pig, the command is pig-version. To start the grunt shell, just type pig. Next is load command. Load command, what it will do is load command in Pig is used to load the data into the system from various data resources. For example, loading data from my HBase, Hive base, book equal to load my book using the HBase storage. Like what it will do is it will make use of the load command. The load command will look for a you can say a data set or database whose name is my book, and using HBase storage method it will load all the data. Done. Now next is normally you are stored where you are loading it from a HBase, it is Hive base. Next is if you are taking it from a CSV file. From CSV file, what you have to do is again book in a variable you are storing. You are using a load method. Inside the load method, what you are doing is you are passing the path entire path of the data set with the .csv extension using the pig storage semicolon. Okay. Loading the data from a CSV file, what you are doing is you're using a load method where you are passing the path of the entire CSV file using the pig storage. This method you are calling this. This is important. Next, when you are trying to specify a particular schema while loading a method, for example, if I want a particular set of attributes only, so what we do is book equal to load method of my book, the name as character array, author as char array, edition as integer, publisher as character array. This is load. Now store. How will you store it? Store is nothing but where you are storing the data. Writes the process data to a storage location. Correct. Default storage is HDFS. Store is processed into pig demo data output processed. Next is HBase. HBase what you are processing into a huge you can say where you are storing the data into a Hive base or you are storing it into a comma separated text. Different ways of storing the data. That's it. Next is dump command. Dump command is mainly useful for displaying the process data directly onto the screen. So what is the command? Dump processed. What are the relational operations in Pig Latin? So first is the for each operations you can perform. So for each, what it will do is it will apply transformation to the data based on columns and is often used to project data. It is a projection operator in Pig Latin. That means it mainly helps to you can say uh, select a particular column from a table. Okay, so for each operation is used. Also you can apply sort operation, group operation, join, project and filter data. Done. Then summary of the commands: load, store, dump and for each. Load is nothing but for loading the data from external source. Store is nothing but you are writing the process data. Dump is nothing but you display the process data. For each allows applying transformations and projections. Now let's see into the difference between Pig and MapReduce. Pig is nothing but data flow language. Your MapReduce was a paradigm. Pig supports high level language. The MapReduce will support only low level languages. It performs, you can say, performing a join, filter and sorting is very simple for Pig, whereas it is very much difficult as compared to MapReduce technique. Also, programmer can have a basic language of SQL only to perform Pig operation, whereas you should know the concepts of core Java in detail to understand MapReduce. Also, Pig uses multi-query approach, whereas your MapReduce multi-query approach, which means that it reduces the lines of the code significantly, whereas the MapReduce technique, what it is, it has the huge lines of code is present to perform one same task. Okay, suppose addition of numbers is done from Pig can be done using 5 lines, whereas 100 lines can be used in MapReduce like that way. So Pig does not require any compilation for execution, whereas long compilation is needed for the MapReduce techniques. Also, your Pig supports nested data types, whereas MapReduce does not support any nested data types. Next is Pig and SQL. Pig Latin is a procedural language. Your SQL is a declarative language. Your schema is optional here, whereas SQL schema is very much mandatory. And relational data model is nested in case of Pig, whereas it is flat relational data model. Next is Pig and Hive, originally created by Yahoo creator. Here it is Facebook. And it makes use of Pig Latin language. It makes use of Hive QL. Pig Latin is a data flow language, whereas Hive QL is a query processing language. Your Pig can handle structured, unstructured as well as semi-structured data, whereas your Hive will only handle the structured data. With this, we mark the end of module 4 of big data analytics. All the notes and everything will be shared in the Google Drive link, so no need to worry about it. Also, important questions from each and every modules will be uploaded. So please stay tuned. Till then, like, share, and subscribe. Thank you, guys.